Hi, welcome to educators.com. This is Shravanti, your Hadoop instructor. In this module, we are going to understand about the data types, the serialization, why custom data types are required, implementing the custom data types and the driver class for the custom data type program. And also we'll be seeing the mapper class, reducer class, and also the custom data type creation as well. But finally, we will be seeing how Cloudera Quick Start PM we are executing our custom data type. If you see the data types, here in the Java we have a primitive data types, by default data types as a boolean, byte, int, float, double, string, long. These are all the data types which we are having it in the Java. But when it comes to the Hadoop, we'll be having the writable data types. That means wherever you wanted to use the boolean, that means the true or false values. So we can use the boolean writable. The bytes, byte writable. Int, we can have either int writable or the int writables. Similar way for the float, float writables and everything. And here in the Java, you will be having the string as the data type, but in the Hadoop, we have text. By seeing this, we might be having a question that why the Java primitive data types we are not using in the Hadoop, why we are having the separate data types in place is nothing but whenever you are working on a distributed environment, all your data, whatever the data input file and whatever the objects are there, it must need to be passed over the network. There is something called a serialization. So what is a serialization process is nothing but whatever the objects which you are having it, this has to be transmitted over the network. So as part of this, whatever the Java data types are there, the Java data types are quite complex. And in terms of the serialization, it is inefficient because it holds the value and also it holds the data type of the each and every object. To avoid such kind of the complexity, in Hadoop, we have something called writable classes. So in terms of with the help of the writable classes, what we are having here is you need not pass any of the data type information over the network. Our files already know about what is the input data type and what is the output data types which we are getting it. So for the serialization purpose, we will not be having any kind of the Java data types wherein we will be using the separate data types for our Hadoop, which implements there is a writable interface is there. So that is the reason why all our data types like int writable, float writable, double writable, these are all the writable interfaces. If you see this, the Hadoop primitive data types, we will be having the writable interface and also the writable comparable interface. And we can see all the data types like a boolean writable, byte writable, int, text, vint, vlong, double. So there is a difference between the long writable and the vlong writables is nothing but whatever the byte size are there, that differs. Apart from that, they both work similarly. So whenever I'm having all these custom data types, all these primitive data types, then why should we create our own custom data type? Is nothing but usually as part of our projects, whenever you get a requirement wherein whatever the built-in primitive data types are there, which we discussed earlier, that are not fitting in your requirement. In that case, what we can do is we can even implement our own custom data type. So how we can implement is nothing but we do have something called a writable interface and writable comparable interfaces. We can, with the help of that, we can write our own custom data type. We are going to see the demo on how we are creating our own custom data types with the help of these writable and the writable comparable. And then when should I use the writable and when should I use the writable comparable? It's nothing but these things are the interfaces in the Hadoop. That means exactly your data types are going to work. Here, as we talk about the serialization, in terms of the serialization and deserialization, our data must need to be converted into a byte stream, and also the vice versa for the deserialization. So if you wanted to do this serialization and deserialization, we must need to have this particular writable. So in simple words, when I can use the writable is nothing but I'm going to create a custom data type for the value, because in the MapReduce everything is as part of the key and value. So whenever I wanted to create a custom data type for the value, I can have my writable. Where in case of the writable interface, whenever you are having the key and value, if you wanted to write your custom data type for the key, then we must need to use the writable comparable, because as part of this shuffle and sort, all our keys are compared with each other to perform this sorting. That is the reason why to do this comparison, we have a compare to and the equals to methods, which are available as part of the writable comparable. So writable comparable must need to be used whenever you wanted to write a custom data type for the key. Writable is for the value, for the new custom data types. So let's see a demo on how we are going to create our own custom data type. Let's see that this is our input file. This is a log file consisting of all the details like input details, and this is a zookeeper log file which consisting of all the information. So what I wanted to find out is, I wanted to find out how many times the info messages or warn messages or error messages have been logged on specific day. That means I must need to read this particular date, and then I also need to read this info or warn or error, and then finally in the reducer I need to calculate the sum, like how many times the count each info messages have been repeated, the warn messages have been repeated in that way. So for that purpose, in the driver class, what we will be defining here is the driver class is same when you compare with the all other driver classes itself. The only difference is we will be setting up the output key class, because in earlier programs when we set up the output key class, we used to define the output key class as int writable, float writables, or double writables, text in such a way. But here, that date error writable is the one, is our custom data type which I am going to create now. That holds the date and also that holds the info, warn, or error. These are all the messages it holds, this new data type. Apart from that, all your program is same, all your driver class is same. And here, this program, I'm going to show you the older Hadoop interface as well, because till now we have seen the Hadoop 2.x, the latest one. So this is the older interface which I'm explaining you right now for this custom data type. So here, if you see the custom data type class, as I mentioned you, we have mentioned in the driver class about the date error writable. So we need to create another class with the date error writable, and which needs to implement the writable comparable, because I'm going to use this custom data type for the key. That is the reason why I'm implementing the writable comparable. And here in this class, you need to write your setters and getters, and also you need to override some of the methods. If you see this public date get date and public date void set date. These are all the getters and setters for the date. That means the first field which you got. In the similar way, you also need to write the setters and getters for the error as well. Like you can see here, set the error and get the error. You need to write the setters and getters. And here we will be having a by default methods called a read fields and write. So these are all the by default methods which we just need to override when you implementing your writable or writable comparable interfaces. And also for writable comparable, additional methods, what we need to do is equals and compare to are the additional methods which we need to set. These two things, equals and the compare to, because all your keys are going to be compared with one another. That is the reason why we must need to set the equals and also the compare to method as well. And then if you see the mapper class, as I mentioned you, this is the older framework program, so you will not be seeing the context.write. Here, instead of the context object, we will be having something called output collector. So in the mapper class, what we are going to do is, we are going to use a string tokenizer and we are going to separate the input based on the comma, so that I'm going to get my entire the date and the days and the hours and minutes as well as the first token. And in the next token, I can see the values related to info, one, and all the other information. So what I'm going to do over here is, I'm going to parse my first field. That means I need to read my year, month, and the day. So how I'm going to get the year is nothing but the index is starting with the 0th position, and once I find out the first hyphen, it is going to be considered as year. And then I'm going to increment the index with 1. You can see it over here. And the next index, once after I increment the next index, here I'm going to find out the month based upon our next index. That is, after hyphen, whatever the value is there, right till another hyphen, I'm going to get that particular month. Similar way, I'm going to get the date as well, day as well. So I'm going to take a calendar object over here. This is the Java method, Java class. With the help of the calendar.set, we can set all our date, year, and the month, whatever you extracted from here. And also the hours, minutes, and seconds also we can set, but we are not concentrating in hours, minutes, and seconds because our agenda is to find out how many info messages, warning, or error messages have been recorded on each day, irrespective of the time. And also here, I am going to get the one, just now I have set it up the calendar.date as well, and now we are setting it up the error methods as well. That means in the next token, I am searching it out whether it consisting of the error or not, or warning or not. So if I see these particular messages, based on this, we are setting up these values. Date dot set the error. Date dot set the error of these values. So how exactly I am setting it up is nothing but, in your date error writable class, we have defined the getters and setters. So in that, we have defined the set the error. So this means what I am doing over here is index of error. That particular token, in case it consisting of the error word, then it returns a positive value. Then we are going to set it up the error to that particular, the date symbol. Finally, I have to emit my context.write, the key and the value. So here, as it is a Hadoop older framework, output.collect is a method which we are going to emit the values. And the date here consisting of combination of the date plus the error. You can see here, date dot set the error, and the previously we have set it up date dot, you can see here, set date. So it consisting of both date as well as the error message as well. So this one is nothing but similar to our word count program. This is normal digit 1, integer 1. because in the reducer what I'm going to do is I'm going to calculate how many times each of my individual combination of the date as well as this info or one messages have been repeated. So in the reducer class, I have simply used the for loop or the while loop, and we can increment the count so that it will display how many times each record has been, each value has been repeated over here. As this is an older framework, instead of directly extending the reducer class, the older frameworks we used to extend the MapReduce base and we used to implement the reducer. This is how we are going to calculate our how many times each and every warning or info message has been recorded and so on so date. Let me show you the execution of this particular program. Yeah. And here I have logged into the Cloudera Quickstart VM and I have attached the input file which is log.out is the input file to process this particular custom data types. Just drag and drop it to your Cloudera Quickstart VM and let's place that particular file into our Hadoop distributed file system with the help of Hadoop FS, copy from local, and here I'm having my file as log.output and here you can call it as some log. And once we have placed this particular file, let's go to our it's done. Let's go to our Eclipse and create a class. As I have shown you, just create a new class and give the name of the classes. And here I have created a class called lcounts, that is a log counts is the class. And if you see this particular class, I have attached the content, you can directly place it over here. And if you see this file, as I have explained you there, here we are setting it up the set output key class as a new custom data type, whichever we are creating. The rest of the driver class is same when you compare with the previous driver class programs. And if you see the mapper class, over here, what we are doing here is we are taking the string tokenizer and separating, and then we are setting it up the calendar object, the date, year, month, whatever I extracted, and finally we are setting up the date.setDate. This is only about the date, but what about the messages like warn or info or such kind of the messages? To set those things, I'm taking that as an X token, and we are considering this as a I'm searching whether the error is there or not in that line, in that token. If it is there, we are setting it up that particular date.setTheError. So whenever these statements are getting executed, it will be going into our date error writable class, because in this particular class, we are writing the methods called setDate and also setTheError. So it will come here and it will be setting up the values from here. And this is the error writable, which implements the writable comparable, and we override the refields write comparable method and also the compare to method and also the equals method. So once it is done, we need to export that, save the files, and let's export that into the jar files. You can call it as custom data types, custom, yeah, we can give the name as the custom data type. Click on finish. What we can do is we can execute that particular custom data type.jar. Hadoop jar, and let's give the jar file as custom data type.jar. And what is the driver class name which we are giving it over here is nothing but our driver class is the lcounts is the driver class, and give the input file which is log, and give the output directory custom data type. Okay, here the n is small case. Let it get submitted. So we are going to see the result, combination of your date and the message and then the total count. Here our program is completed successfully. You can see it over here, and to verify our output directory, just navigate to Hadoop ss-ls and see the part file. Yes, we have a success file, and to see the part file, this is an older framework. We have directly got the part-0 results. Otherwise, we would have seen part-m or else the part-r results. Like this, you can see the in your input file, you are having the date as this, and the time we have set it up as we are not considering the time at all. So we have simply taken it out as a 0, and we have seen the info has been repeated 25 times and the warning is repeated one time as part of our input file. This is how you are going to calculate the custom data type, because to find it out, the highlighted ones, that means the combination of the date, time, and these messages, we do not have the specific data type. If I'm going to use the text, it takes a lot of time to process. To improve the performance, you must need to identify whenever you require the custom data type. Whenever the primitive data types are not sufficient to suffice your need, you will be creating the custom data type by simply implementing the writable or the writable comparable methods, calculating these things like this. Summary. So in this module, we have seen how to create our own custom data types. And what is the need of these Hadoop data types when we have the primitive Java data types? We understand the serialization, and we have seen how to write our own custom data types by implementing the writable or writable comparable. And also we have seen that writable interfaces mainly to specify the custom data type for the value. The writable comparable is to specify the custom data type for the keys. Thank you. Let's catch up in the next module.